Hello students, welcome to the 12th session of sets. In the previous session, we have discussed about the questions from 6 to 10. Now in this session, we will be discussing about the questions from 11th onward. In 11th question, it says that let A and B be sets if A intersection X, that is, X is a capital X, or a set, is equal to B intersection X is equal to empty set, and A union X is equal to B union X for some set X. Show that A is equal to B. So now here under this condition we have to show that A union A is equal to B. That means we have to show that A is a subset of B and B is a subset of A. Isn't it? We have been doing this kind of a conditions in all the questions we have done in the previous session. The same way here we are going to take it. Now here we need to think about the question. It says the conditions that A intersection X is equal to B intersection X is equal to empty set. So that means that there is no element common between A and X, and there is no element common in B and X. So that's why this result is empty set. Yeah. So here we assume let X, here we are taking X as an element, arbitrary element which belongs to set A. So if it belongs to set A, so then it will belongs to A union X, isn't it? The union of A and X, that will be, it can be, and this will belongs to B union X as it is given A union X is equal to B union X. So here that it does not belongs to B intersection X, in that we can say that B intersection X is already given, that is an empty set. So this we need to keep in mind, and further we can say that when X belongs to B union X, so it will belong to B or it will belong to X. So if it belongs to B, so here it will belongs to A also, that we have assumed here, that we have taken X belongs to A. So when X belongs to A and X belongs to B, so then we can say A is a subset of B. And here if we say X belongs to set X, so X will belong to A intersection X and X will belong to B intersection X. So here it is given that A intersection X is equal to B intersection X, and this is equal to empty set. So here it will belong to empty set. So then we can say there is in empty set there is no element. So when there is no element, so we can say X is no such element which will present in X. I hope it is clear. Now we prove it to the reverse. So here we take it as the arbitrary element Y belongs to B, and B, that Y belongs to B union X, and Y belongs to A union X as it was given in this question also, that it belongs to A union X. So here we say Y belongs to A, so then we can say B is a subset of A, isn't it? So B is a subset of A, and here again if we say that the Y belongs to set X, so it will belongs to B intersection X, so it will belong to A intersection X as it was given in the question itself. A intersection X is equal to B intersection X is equal to empty set. So here again we get Y is equal to, Y belongs to empty set. We can say there is no such element Y which is present in empty set. So here we have solved both the condition that A is a subset of B and B is a subset of B. So from this statement 1 and 2 we can say A is equal to B. Okay. Now we move to the another question, that is your question number 12. So question number 12 is very easy. If you see, it says you need to find sets A, B and C such that A intersection B, B intersection C and A intersection C are non-empty set. They are non-empty set, and there is another condition that A intersection B intersection C will be empty set. So here you need to find out the sets where we need to find out the set A, B and C. You need to use a certain common sense that how we can have such a set where A intersection B, B intersection C, A intersection C will have a certain elements, but their intersection of all the three sets will be empty set. Okay, so it may vary. So I am here just simply showing you the certain sets, but this may vary from person to person, whatever you think that it should follow the, or it would satisfy the intersection rule here and intersection rule of all the three sets. Clear? So here I have taken 1, 2, A as a, B as 2, 3 element, and C is a 1, 3 element. If I say that A intersection B is 2, B intersection C is 3, and A intersection C is 1. So here we have the A intersection, all the three elements sets we see. So A intersection B intersection C is empty set. Okay. Now we move to the another question, that is a question number 13. So what does the question number 13 says? So here you say that it is in a survey of 600 students in a school, 150 students were found to be taking tea and 225 students taking coffee. 100 were taking both tea and coffee. Find how many students were taking neither tea or no coffee. Now this question, if you do it with the help of the Venn diagram, so then it will be very easy for you, as we have done in the exercise 1.6. In the 1.6 we have done the question based on a Venn diagram. So similarly here also we will be doing the question based on the Venn diagram. The first we will assume that the set of T, that let T be the students who are taking T be the set of the students who are taking tea, and C with the set of students who are taking coffee. So here we represent it as per the question that the cardinal number of union is taken as that all the sets of the students, that is we are taking as 600, and the number of students who are like tea, so that will be 150, and number of students who like coffee, that is 225. Okay, and number of the students who like both tea and coffee, they are 100. So if you see that I have represented in the help of the Venn diagram, so U is taken, this rectangular box is taken as a universal set 600. So here we have taken 150 who the students who like tea. So this whole is your circle, that is your tea, and this whole circle, that is your coffee. The 225 are the students, they are the number of the students who like tea as well as coffee, that is 100. So if you see the working, I have done it inside the circle, that is 125 like coffee, and here 50 like tea only. Here tea, this portion is what? Tea only, and this is your only coffee. So this is represented, and it says you find how many students were taking neither tea nor coffee. So if we take that this is a union, or that this is a T union C, this number of the students will like either tea or coffee. So it is asking neither tea or coffee. So neither tea, coffee, that means leaving the number of students who are liking this thing. So that means that we need to subtract this A union B from universal set, isn't it? So what we do, so here we say that is cardinal of T complement intersection C complement. So we will get cardinal of T union C complement. So here we will have the cardinal of U minus cardinal of T union C. So this we subtracted. So we will get the number of the students who don't like neither tea nor coffee. So we know T union C will be cardinal of T plus cardinal of C minus cardinal of T intersection C. So here we get 275. So here we get 275 as the people or the students who like tea or coffee. But here we require that 600 minus 275, that is 325 people who like neither tea nor coffee. I hope this thing is clear, and with the help of diagram that we can find it out also, that find the number of students who like only tea. So if only tea, so this 50 will be there. If it is asked only coffee, then it will be 125. I hope this is clear. Okay, and next question what it says? It says that in this one, it says in a group of students, 100 students know Hindi, 50 students know English, 25 students both. So each of the students know either Hindi or English. How many students are there in a group? It will done in the same representation. The major thing is it says ki how many students are there in a group. So here the union is not given. So now you need to understand this portion in the more clearly. So here we have done in the same manner. This you can say that the cardinal number of U, we need to find it out. That is number of students who like Hindi, that is speak Hindi, that is 100, and English, that is 50, and both the languages, that is 25. Clear? So each student know either. Here it says the condition ki each of the student knows either Hindi or English. That means ki it says ki there are no such students who don't like either of the language. So now we can say that is the cardinal of A union B is less than equal to union set. Maximum it can happen or not. So but here it says ki that either of the yani ki every student knows Hindi or English. So you need to find out, so then it will be your A union B, isn't it? So as given, so here we can find out the A union B. So this will be the same formula, and we will find it out that will be 125 students in a group. I hope this thing is clear to you. This is the way that you will be doing. Most important thing was that how you will find out this relationship you need to remember. Okay. Now we move to the 15th question where the 3 sets are used. 3 sets, it says in a survey 60 people, it was found that 25 people read newspaper H, 26 read newspaper T, 26 read newspaper I, and 9 read both H and I, 11 read both H and T, and 8 read T and I, 3 read all the 3 newspaper. And you have to find it out with the number of people who read at least one page of the newspaper. I hope it is clear. At least one of the newspaper. And second one, it says ki number of people who read exactly one paper. Okay, at least means what? Ki that one of the paper they are able to read. Yani ki they are reading either minimum, if you say in Hindi, kam se kam, that will be known as the at least one newspaper. So what we have to find it out here. So let's see the representation. So here in the Venn diagram, this way it is being represented. So here the detail which you will note it down like this, and you draw the Venn diagram. So you see that the H, the newspaper H is being read by 25. That means that this whole will be taken. 25 I have written outside, and for T I have written 26 here, and this I have written 26 here. So this is the number of the people who are liking or reading the newspaper H, T and I respectively, and they are the people who are reading both the paper, that is your 11 H and T, that is your 11. So here I have written it outside as it contains all the 3 newspaper. So all the 3 newspaper is what? Number 3, which is written in center, and 6 is here, 5 is here. So this is, it will comprises 9, and this will comprise 8, and this will comprise 11. Okay, so this way, and here it says ki at least one newspaper. So at least one newspaper, so we will find out the H union T union I. So we are doing the union, so all the common news readers will be taken as ones. So here we will be using the formula cardinal of H union T union I, and we will be placing the value we will get as 52. Now the second question, it says the number of people who read exactly one paper. So exactly one paper means ki only H, this one, only T, this one, and only I. So then we can say ki exactly one paper, so not other paper. So here we will have, this way we calculate it, and for this we need Venn diagram to solve it. So here we get 8, 10, 12. When we add it up, so we get 30. With the help of Venn diagram, we can find out the various solution. So if suppose if it is given they find the number of people who read neither of the paper, that means they don't read any of these paper. So what will happen? The universal set minus AH union T union I. So if you see that H union T union I that we have found out 52, so we will subtract it from union set, so that is a cardinal number of U minus cardinal number of A. This is H union T union I. So we will get that 60 minus 52. This here we will get it what? 60 minus 52, that will be equal to 8. Suppose if they ask the exactly two papers, so when we are talking about the exactly two papers, so here 8, 6 and 5. Is it 8, 6 and 5. 8 are the people who are reading H and T, and 6 are the people who are reading H and I, and T and I is read by 5. So 8, 6, 14, 14 plus 5, that will be 19 number of people who will be reading exactly two papers. I hope this thing is clear. Okay, so this is the way it will be done. Now we just see the 16th question. What does the 16th question says? Here it says, in a survey it was found that 21 people like product A, 26 like product B, and 29 like product C. Now here again there are the three sets are here. Three sets A, B and C. And if 14 people like product A and B, 12 people like product C and A, 14 like product B and C, 8 like all the three product. Now here we have to find out that like product C only. So do we have any formula to find it out? No. So here we will use the Venn diagram, see how it will be done. So here we are taking the Venn diagram. So this I have written all the details which I have read it out, and this will be represented A, B and C. I have written that A, product A, the 21, product B 26 and product C is 29. Now it says product A and B is 14. So A and B 14, that this will be here, and A and C is 12. A and C, that is 12 this here, and B and C 14, here it will be B and C 14, and here A intersection B intersection C, that is equal to 8. This I write it here. So only C means that we need to find out this much. That means that this whole thing is to be subtracted from set C. So here we have got 8. So this his whole thing is 12. So 12 minus 8, this will become 4, isn't it? And here we have this whole thing as 14. So 14 minus 8, I will get it 6. Now this whole thing is 29. So 29, so what will be only this part? So this part will be 29 minus sum of these three values. So this will be 14. 14 plus 4, 18. 18 minus 29. So sorry, 29 minus 18. So 29 minus 18 will give you, that will be 11. So here 11 will be the only number of people who like that set C, that is a product C only. So for this, if we have the question that find the number of people who like at least one product. So when we are talking about the at least one product, so here it will be A union B union C, as we have done in the previous question. And if it says exactly one product, so then it will be all the onlys will be added. So here we get it here 14, I am having this will be 6. So this will be your 10, 18 and 21 minus 18. So that will be your 3. And here 26 minus 20. So this will be 6. So at exactly one product, so 11 plus 6, 17, 17 plus 3, 20. 20 people were the people liking only exactly one product. Exactly true product. So 6 plus 4, 10, 10 plus 6, that is 16. This is the way that you will be doing it. Here most of the places I have explained you, I have not written down the statement, but you will write it down the statement to support your answer. I hope these things are crystal clear to you all.